Welcome to the penultimate linear relations video on tangents of lines and perpendicular lines. What is a tangent and perpendicular line? Well, we'll come to that in a short while, but as is normal, let's go over the type of language that we will be looking at this particular video. So as I say, we have tangent, gradient, perpendicular and trigonometry. Now, one of the things I will say is that if you have no understanding of trigonometry, you might want to stop this video now and go back and look at one previously on trig. It's sort of going to make sense on the first section of the video as I'm going to recap it. So let's do that now. What is trig? Well, trigonometry is relating to the idea of a right angle triangle whereby you have an angle, and as a result of that angle you can label your sides to be the opposite, the adjacent and the hypotenuse, where the hypotenuse is always the longest side. And there are three relationships, trigonometric identities, which are linked together by the ever so helpful SOHCAHTOA. Thank you, Simon. I'll say that one more time. SOHCAHTOA for Simon. What does SOHCAHTOA actually mean? Well, if we spell it, we have SOHCAHTOA, which is probably the most stupid word I've ever used in maths. That and supercalifragilisticexpialidocious, which I will say backwards later. But the idea of SOHCAHTOA is that we can split it up to help us remember the concept of sine of an angle is equal to the opposite over by the hypotenuse. We have the cosine of an angle is given by the adjacent divided by the hypotenuse. And we have the tan of an angle is given by the opposite divided by the adjacent. And so, well, that's a pretty quick recap of SOHCAHTOA. Maybe the one I want you to realise that's going to become most important is this tan theta is equal to opposite over adjacent. So let's look at how this might be important for our linear relations. Well, out comes a large whiteboard and we'll put on a straight line. Now, in this particular instance, I've got the straight line measured here, and I've drawn two lines as well. I've drawn a vertical line and a horizontal line. Now, we could, if we want to, put ideas on here that this has an intercept of 3, and this could have the equation y equals 6x plus 3. I mean, it could do, but that's actually not the important information at this moment in time. Let's go back to our trig. We're looking for right angle triangles, and as it now happens, here I have a right angle triangle. So that would suggest that an angle of theta could be written here. Now you'll notice that that angle is actually taken with respect to the positive direction of the x-axis. Remember that expression, the positive direction of the x-axis. Here is the x-axis, and this is the positive direction. So almost, the angle it's making with the x-axis itself. So if I've got an angle here, can I label the sides? Well, I can label the sides, but I'm only going to label two of them. If this is my angle here, this is my opposite side, and this is my adjacent side. And from the previous screen, we know that tan theta is equal to opposite divided by adjacent. But if we actually have a straight line, and we have these lines on as well, well, if we had two coordinates, we would be able to say also that gradient of the line is equal to rise divided by run. Well, that means this bit here is rise, and this bit here is run. So actually, we can see from just this simple piece of mathematics that opposite over adjacent must be exactly the same as rise over run, which means actually that the tan of the angle must be exactly the same as the gradient. Why is that true? Well, if these two things here are the same, then tan theta and gradient must also be the same. So we can write that in a formula, that the tan of the angle is equal to the gradient of the line. Or we can find the angle by doing the inverse tan of the gradient. Well, how do we find the gradient of a line? Well, we've done lots of that. It depends on how the question is phrased. So you could either be given the gradient here for the number in front of the x, which is the gradient form, or we could be given two coordinate positions, and we could find the gradient using rise over run. But perhaps one of the most important formulas you're going to be using for the moment is that tan theta is equal to the gradient. Well, that's pretty important, and let's just introduce one more concept before we do a couple of examples. And I'm going to bring up a couple of lines. These lines actually have a right angle single in between them. So here they are at right angle to each other. Now, lines that are right angles and meet at a right angle are called perpendicular. And excuse my handwriting, but perpendicular. These lines are perpendicular. In a previous video, we were talking about how would the gradients of perpendicular lines actually be related. And a lot of people make a mistake by saying that if you have y equals 2x plus 6 and y equals minus 2x minus 4, that these lines must be perpendicular because the gradients have a minus sign in front of them. And while in a lot of maths a minus sign actually does mean the opposite, it doesn't in this case. There is a lot of theory behind the idea of perpendicular gradients, and I'm not actually at this moment going to go into the theory. What I am going to tell you is that they are related. I'm going to give a couple of examples first, and what I'm going to say to you that the gradient of a half is perpendicular to a gradient of minus 2. The gradient of minus 2/3 is perpendicular to the gradient of 3 upon 2. And the gradient of 3/5 is perpendicular to the gradient of minus 5 upon 3. Now hopefully with those three examples you've now come up with the general rule that tells you that to go from the gradient of a line to its perpendicular, you actually swap the top and the bottom numbers and change the sign, or you take the reciprocal and inverse the sign or reverse the sign. Really? 1 over 2 becomes 2? Well, yeah, just remember that that becomes 2 over 1. A positive becomes a negative. Let's just check it works here. The gradient of minus 2 over 3 becomes the gradient of plus 3 over 2. Yep, the 2 and the 3 have swapped places, and a minus becomes a plus. And in this situation, 3 over 5, does it swap? Yep, 5 over 3 and a minus. So we can now say that the gradients of two lines are just the inverse and negated. But how do we say that in terms of a formula? Well, in many cases, if we call this gradient m1 and we call these gradients m2, then what you'll find most textbooks say is that the definition of perpendicular lines is m1 multiplied by m2 becomes equal to minus 1, or m1 is equal to minus 1 over m2. Well, just let's go through that very quickly. What does that mean? Well, m1 is minus 1. Well, if you take 1 over a number, it's the reciprocal. It means it flips it upside down. And that minus sign literally just changes the sign. Pretty much what we've got. So once again, we can say that m1 multiplied by m2 is equal to negative 1. Does that work with each of our values here? Well, let's just take one of them and see what happens. If we were to take a half, and we were going to multiply it by minus 2 over 1, what does that give? 1 times minus 2 is minus 2, 2 times 1 is 2, and minus 2 divided by 2 is in fact minus 1, and so I'm ecstatic. This formula down here, this gradient of perpendicular lines, is also really important. But again, I'd like the shortcut, flip it upside down and change the sign. Let's look at some examples now. Nice and easy one to start with. We've been given two coordinate positions and they want us to find the angle that those 2 points make with the positive direction of x. Now remember, they want to know the angle the line makes with the positive direction of x. And if we think about it, we've got two coordinate positions, 2, 6 and minus 2, 4. Let's just draw a very quick sketch of what that might look on a set of axes. So here's my axes. Where will 2, 6 be? Let's say roughly speaking here. And where will minus 2, 4 be? Let's say sort of here. And if we were to draw that line together, right, we're looking for this angle here, the one I'm currently colouring in. Right? Not a great diagram, but we'll go for it. So now we've got our two coordinate positions, and we know that to find the gradient of our two coordinate positions, you do the y values minus each other divided by the x values. So we now know that gradient is equal to, well, our y values, which is 4 minus 6 divided by minus 2 minus another 2. Well, 4 minus 6 is minus 2. Minus 2 minus 2 is minus 4. So my gradient actually works out to be a half. Well, how does that help us with our angle? Go back to our previous knowledge. Remember that we also know that tan theta is equal to gradient. Well, we now know our gradient. Our gradient is a half. So we know that tan theta is a half, which means theta must be tan to the minus 1 of a half. There is no quick way of doing it, so you can't do this in your head. You have to use your calculator. So tan to the minus 1 of a half is 26.57 degrees to 2 decimal places. And that is my answer. So the angle these 2 points make with the positive direction of the x-axis, or this angle here, which I'm now colouring in blue, is equal to 26.57 degrees. Easy, really. Using our previous knowledge, find the gradient, make sure it's equal to tan theta, find my answer. That was pretty easy. How else can they trick us? Trick? Did I hear you say trick? Are you trying to suggest that maths is a big fat trick? Well, maybe just a little bit. One of the biggest tricks of all is to use algebra, and here we have the line y equals x plus 1. We should all now be happy that that is a straight line. It has a gradient of, oh hold on, what gradient does it have? Remember, all lines, straight lines, can be written in the form y equals mx plus c, and if we write y equals x plus 1, what's the one number that we can miss out but that is really important? Yep, x is the same as 1. So they're just trying to trick me. What they're telling me here, in code if you were, was that gradient of that line is equal to 1. Well, if the gradient is equal to 1, that means that tan theta is equal to gradient. And so tan theta is equal to 1, or theta is tan to the minus 1 of 1. And again, using my calculator, I can find out that that's actually 45 degrees. And a very quick sketch, if that's my equation and this is my positive x value, then it's saying that the equation y equals x plus 1 would have an angle of 45 degrees. Right? So just be very careful to make that clear. It has a gradient of 1, but it has an angle of 45 degrees. It can't get any more complicated than this, can it? Nah. Let's look at this. 2y minus 2x equals 6. It's just trying to trick us. Because remember, maths is a big, fat trick. This 2y minus 2x equals 6 is simply written in intercept form. Well, to get the gradient for that, we just rearrange it. So we want the minus 2x to move over to the other side, and that leaves the 2y is equal to 2x plus 6. And because we want y equals, we divide all of that by 2. And because we're pretty clever, we know that we can split that up into 2x over 2 plus 6 over 2, or x plus 3. So therefore, my equation has y equals x plus 3. What's my gradient? Well, it's the number in front of the x in this form. So once again, my gradient works out to be 1. And using the rather fabulous, if not now, really easy idea that tan theta is equal to gradient, that means that tan theta is equal to 1. Theta is tan to the minus 1 of 1, or theta is once again 45 degrees. Easy. I think you pretty much got all the learning. Enjoy. Oh, and if you want to shout out on any of the videos, just email me. Email address to come at the end. Have a great day.